let's talk about definite integral of even and odd functions. So still remember what even function is. So if a function is even, then f of negative x is just equals to f of x. So one popular even function is f of x is equals to x squared. This is a very popular even function. So if you do the testing, you replace the x with negative x. That means on the other side, you replace the x with negative x. After you square that, you will just go back to x squared. So you just prove that f of x is equals to f of negative x is equals to x squared. Then you just prove this. All right. So what is the graph of x squared? That is a parabola right here. So you have a parabola. This is a x. This is the x squared, right? And then this is the y-axis. This is the x-axis. What about odd function? So odd function is you have f of negative x that is equals to -1 times the entire function. One popular odd function is you have f of x equals to x to the third. This is a very popular odd function. Then you replace the x with negative x. Then on the other side, you have a negative x raised to the third power. So negative times negative times negative, you still have negative, right? So that is equals to -1 times x to the third. Then you just prove that f of negative x is equals to negative f of x. All right. So the graph of this, so let's sketch the x and y axis, is equals to this. Okay, and then this is called origin symmetry. Actually, you don't need to worry about that. That is origin symmetry, and then the x squared is y-axis symmetry. How do you apply this indefinite integral? So indefinite integral, so let's do the even function first. So let's say you are doing the integral from -3 to 3 x squared dx. So how do you sketch this? So this is, let's say this is a -3, this is a +3. So when I ask you this kind of question, that means I am looking for the entire area in here and here, right? So since x is an even function, this integral is equal to, we can break this down into two integral like that, from -3 to 0 x squared dx, and then plus from 0 to 3 x squared dx. They are equal. And other way to do this is that is equals to 2 times from -3 to 0 x squared dx, or 2 times 0 to 3 x squared dx. What is the benefit of doing this? The benefit of doing this is if you plug in the 0, the fundamental theorem of calculus should not be too hard to evaluate. So let's do this again. So when I ask you to evaluate this integral, that is the same thing as doing this integral plus this integral. Or you can make the math more convenient by just do this first, from -3 to 0. So from -3 to 0, and then you will get this area, right? The area on the left. And then whatever the answer equals to, you multiply by 2. Because the piece on the left of the y-axis is equals to the piece on the right side of the y-axis. So the left side and the right side, those two pieces, they are pretty much the same. How do you know that they are the same? Because they are both from negative, they are both 3 units away from 0. But if you have that, if you have an integral like this, from 0, from -5 to -3 x squared dx, that is another story. Right? That is another story. So that is an important characteristic of the even function. What about odd function? So for odd function, let's say I want you to do this integral. Let's say from -4 to 4 x to the third dx. So this is actually the graph is not looking too good. This piece is not looking too good. So let's just fix that a little bit. So let's make it look like that. All right, much better. So -4 and 4. So let's say this is +4, and then this is -4. -4. So with this integral is asking you to add this area and this area. What is that equal to? You can tell the answer right now. you don't even need to evaluate the integral. The answer is equals to 0. Why? Because the area below the x-axis is negative. How do you break this down into two integrals? This integral is the same thing as from negative 4 to 0, x to the third dx, plus from 0 to 4, x to the third dx. The one thing that I can tell you is this is going to be negative, and then you plus this is positive. That is equals to 0. Whatever that is. Let's say from negative 4 to 0, the answer is equals to negative 10. That means the other piece must be positive 10. Then you have a negative 10 plus a positive 10, which is equals to 0. So that is one thing you can do when you evaluate the definite integral using the even and odd function. But if the function is very complicated and you can't get the graph of it, then it is hard to apply these two rules. All right, so that is the end of this video. If you think my instruction is helpful, let me know in the comment below. Like the video, share the video for me, subscribe to my channel if you haven't done so. As always, see you all in the next lesson. Signing off for now.